Thanks for making it the Russell Institute. Today we're going to be talking about completing the square when the coefficient of x squared is 1. So we're talking about quadratic equations, and quadratic equations have the form ax squared plus bx plus c equals 0. So when the coefficient of x squared is a, and when that is equal to 1, we have a bit of a simpler situation, and that is what we're going to be dealing with today. Completing the square is a way of expressing a quadratic equation that makes it easy to solve, but also extremely easy to graph, which is important because otherwise it can be a little bit more difficult to grasp what the graph looks like. So quickly, let me just cover the concept of a perfect square in algebra. So we're talking about algebraic perfect squares. So whenever we're talking about an algebraic perfect square, what we really are referring to is something like a binomial x plus 3 all squared. And for those of you who are very good at algebra, you will remember that this means x plus 3 multiplied by x plus 3. And then for those of you who are not so great, let me just do this with a color code to show you what's happening. I'm going to multiply every term in each bracket by every term. So x multiplied by x gives me x squared. And I'm going to take that same x and I'm going to multiply it by 3. That will give me 3x. Then I'm going to use 3 now and multiply x, and I'm going to get 3x. And finally, I'm going to come around here and I'm going to take the 3 and multiply it by the 3, and I'm going to get 9. And that gives me a final answer of x squared plus 6x plus 9. Now, this whole thing, actually, there's a shortcut because there's a clear pattern that happens here. If you look, the first term is squared. X squared gives me, well, x squared. The second term is what we call the cross term. I use yellow for the cross term, which means you're multiplying these two things by each other. Each term in the binomial, you're multiplying it by each other 3 times x, but that thing is doubled. As you can see, there are 2 3x's in the expansion. Let me show you. There are 2 3x's in the expansion, so this thing gets doubled. The cross term is doubled, so that's the 6x, and then finally the last term is squared as well. So the first term is squared, the last term is squared, and the middle term is the cross term that is doubled. So we can actually find the perfect square very quickly. And we're going to use that concept when we're completing the square because it's a bit of us going in the reverse, because x squared plus 6x plus 9, that's a quadratic expression. And so I can actually take this quadratic expression and then move it back. I can actually take this quadratic expression and move it back to the perfect square, and that process is called completing the square. So let's actually do an example. So I have x squared plus 6x plus 5, so I want to do that. So this 6x is going to be my cross term, so I'm going to go backwards here. I'm going to do half of this 6, which is 3, x plus 3 all squared, and then I haven't used my plus 5, so I'm going to carry it down. I'm going to have plus 5. Now I can't just leave it here because I've added something to the equation and I need to balance it. So let's try and figure out what we added to the equation. X plus 3 all squared, we know that it's going to be x squared. We're going to have our cross term multiplied by 2, 3x times 2, 6x, and we're going to have our last term squared, which is plus 9. That's x squared plus 6x plus 9. So if we look, x squared plus 6x was here already. So that's good because we're saying that these things match. X squared plus 6x, x squared plus 6x. These things match. However, plus 9, that was not there before. So we've added a whole 9 to the equation. So this thing can't be equal to 0 anymore unless we subtract 9, therefore making it equal to 0 again. So if I'm to expand this x plus 3 squared, I know I'm going to get x squared plus 6x plus 9. Those 9's cancel, and then I am back to where I have begun. So let's continue this thing and simplify. X plus 3 all squared. 5 take away 9 is negative 4. This is, the square has been completed. We have completed our square because we have our perfect square here. All right, and everything is lovely. And if we want to go ahead and continue, we can simply solve this thing now by simply saying, well, x plus 3 all squared is now equal to 4. And I can go ahead and solve this by taking the square root of both sides. Once I take the square root of both sides, I'm going to realize that, well, x plus 3 is actually equal to either positive or negative 2. So I have two situations, which is true because every quadratic, well, not every quadratic, but most quadratics will have two possible solutions. So I'm going to say, well, x is either equal to 2 take away 3, or x is going to be equal to negative 2 take away 3, which leaves me with x equal to negative 1, or x is equal to negative 5. And there you have it. That is how you complete the square when the coefficient of x squared is equal to 1. Thank you for making it the Russell Institute. Don't forget to leave a like or subscribe. You may have a chance to win some free Digicel or Lime credit.